Let's see what other things we can do with our sum and difference identities for cosine. As an example, let's try to simplify this expression. It looks like something that we wouldn't know how to deal with, because we don't know what cosine of 22 degrees is, or cosine of 8 degrees, or any of these values. But the thing to notice here is that this pattern is very familiar to our formula for the sum of two angles. So notice here that if we just relabel 22 degrees, if we think of that as alpha, and we think of 8 degrees as beta, well, then we have 22 degrees over here again, alpha, and 8 degrees is beta. This is exactly the pattern for cosine of alpha plus beta. So once we notice that, we realize that this is just equal to cosine of alpha plus beta. And in this case, our alpha is 22 degrees and our beta is 8 degrees. So this is cosine of 22 degrees plus 8 degrees, which is cosine of 30 degrees. And we know what cosine of 30 degrees is. It's root 3 over 2. So that is how we can simplify an expression that otherwise looks like we wouldn't know how to do it. Now let's do one more example like that one. So now we have another expression. Now we have another expression to simplify. Cosine of 72 degrees times cosine of 12 degrees plus sine of 72 degrees times sine of 12 degrees. And again, this looks like something that we wouldn't know how to do because we don't know offhand the value of cosine of 72 degrees or 12 degrees. Those aren't standard angles in our unit circle. But we can figure out how to do this by, again, recognizing the pattern, right? We see that this is of the pattern that we had for the difference of two angles, our difference formula for cosine. So again, if we think of this as alpha and beta, so 72 degrees is alpha, 12 degrees is beta, then again we see that this is exactly the formula for cosine of alpha minus beta, right? Remember that cosine of alpha minus beta had the plus sign between the terms. So in this case, again, alpha is 72 and beta is 12, so this is just cosine of 72 degrees minus 12 degrees, which is cosine of 60 degrees. And we know that cosine of 60 degrees is a half. So that is an example of how we can simplify an expression using the difference formula for cosine. All right, now let's look at another thing we can do with this cosine difference formula is we can actually verify or simplify certain trigonometric expressions. So an example of something that we can do is to simplify cosine of pi plus x. And there are a whole bunch of identities like this where you can rewrite cosine of something in terms of sine of something else. And there are a whole bunch of them, and you can try to memorize them. But if you ever needed to figure out what something like this simplifies to, you can actually figure it out. So let's see how we can simplify cosine of pi plus x using our sum formula for cosine. Well, we know how to deal with a sum of two angles, or cosine of a sum of two angles. It's cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. And now we just need to use some of the trig values that we already know. We already know what cosine of pi is. We know what sine of pi is. So we can use those to simplify this a little bit more. So what is cosine of pi? Remember, cosine is -1 at pi. So we have -1 times the cosine of x. And sine of pi, remember, that is 0. So 0 times sine of x. So this whole term just goes away because it's 0 times sine of x. So this term goes away, and we're left with just negative cosine of x. So we get minus cos of x. So this is an identity. We have just shown that for whatever value of x you plug in here, we found that cosine of pi plus x is just minus cosine of x. And there are other ways you could see that that's true by considering the unit circle or other things. But the point is that we can prove a whole bunch of identities like this just by using our sum or difference formulas for cosine. So let's do one more example, just like what we just did. Now we're going to simplify cosine of x plus pi over 2. And again, we can just use the same pattern that we just used in the previous example. So we can just expand using our sum formula. So remember, cosine of the sum, we get cosine of the first angle, so cosine of x, times cosine of the second angle, in this case pi over 2. And then we have minus sine of the first angle, so sine of x, times sine of the second angle, which is pi over 2. So that is something that we can now simplify. Remember, we know that cosine of pi over 2, now we're at 90 degrees, we're up at the on the y-axis, and that is where cosine is 0. So this is 0. And sine of pi over 2, well, that is 1. And so this term goes away because it's cosine of x times 0. So this whole term goes away, and we just get minus sine of x. And so we see that cosine of x plus pi over 2 is just minus sine of x.